So we're going to be exploring operations with rational and irrational numbers. And then we're going to get back to exponents. What happens when you add two rational numbers is what we're going to find out. We're going to see if the results are rational or if they can be irrational. And the same thing with the sum of irrational numbers. Will they always be rational or irrational? And just remember real quick, a rational number is a number that can be created by dividing an integer by an integer. This would be rational. An irrational number, right, would be like square root of 5 would be irrational. There's a lot of them, right? There's pi, there's a lot of things you'll discover later, but irrational. I'll point them out as we go down here. All right, so this is an addition table, and we're going to go across, and for instance, negative pi or negative 2 pi. Negative pi and 7 is just 7 minus pi if I add them together. 1/4 and negative pi is 1/4 minus pi. 0 negative pi is just negative pi. Rad 3 and negative pi is rad 3 minus pi. And negative rad 3 minus pi is negative rad 3 minus pi. So if I keep going, you're going to see some patterns, right? You can only add like terms. So this is 7 minus pi. This is 14. This is 7 and 1/4. This is 7. This is 7 plus rad 3. You'll notice I put it in a different order than I did up here. I like my rational numbers before my irrational numbers. They're still not like terms, so we just set them next to each other. And this is 7 minus rad 3. So this is 7 and 1/4 still. Ooh, I'm sorry. I did that wrong. I was looking at the next number. This is 1/4 minus pi. 7 and 1/4. Ooh, 2/4 or 1/2. 1/4. I like these. Those are nice and easy. 1/4 plus rad 3. 1/4 minus rad 3. Right here. Negative pi, because that's 0. And everything, all of these, this is 0. This is just going to be the number itself as I go down. That's kind of a nice one. Rad 3 minus pi. 7 plus rad 3. 1/4 plus rad 3. Rad 3. And I like this one. Rad 3 and rad 3. 2 rad 3. Rad 3 minus rad 3 is 0. So there we've got a situation where we started off irrational, we turn irrational. Negative rad 3 minus pi, not like terms. Negative rad 3 plus 7, either order. 1/4 minus rad 3. Negative rad 3. Alright, this is 2. Oh, no it's not. This one is. We got negative rad 3 and a positive rad 3, which is 0. And this is negative 2 rad 3. Based on the results, will the sum of two rational numbers sometimes, always, or never be rational? Well, let's go sometimes, and we'll give ourselves an example. For instance, negative rad 3 plus rad 3 was 0. Alright. We also at some point had, well, where's it at? No, that's it. That was our example up there. Alright. And let's see what's on the next page. What about the sum of, I think I might have read this wrong. Will the sum of two rational numbers be rational? Well, I just lied to you, because rational numbers always will be rational. Irrational numbers will sometimes, with the example that we said. For instance, we've got negative rad 3 plus rad 3 equals 0. Finally, the sum of a rational number and an irrational number, always irrational. Alright. Now let's look at one more here. Now complete the table following multiplication. Okay, so now we're multiplying. This is negative 7 pi. This is negative 1/4 pi. Ooh, this is 0. I like this column. Let's do this whole column. It's going to be 0, 0, 0, 0, 0. This is negative rad 3 pi. I should put the pi in front, otherwise it looks like it's under the rad 3. And this is negative pi over rad 3. Here we go. Negative 7 pi. 49. 7/4. 7 rad 3. 7 over rad 3. This is negative 1/4 pi. 7/4. 1/16 when I multiply. Rad 3 over 4. 1 over 4 rad 3. Oh, here we get another 0. 0, 0, 0, 0. This one's 7 rad 3. Rad 3 over 4. Ooh, here's a good one. Look, rad 3 times rad 3 is rad 9, which we know is just 3. And this one, look, rad 3 over rad 3 equals 1. We know that's going to be down below. Negative pi over rad 3, 7 over rad 3, 1 over 4 rad 3, and this one's 1 because you get rad 3 over rad 3. And this one is 1/3. So based on this, will the product of two rational numbers sometimes or always be rational? Always. Right? Two rational numbers, here, 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 always rational. What about two irrational numbers? We're going to say sometimes. We'll give an example. We'll do, what we got? Rad 3 times rad 3 is rational. It's just 3. Finally, the product of rational and irrational. We're going to say sometimes. I'll give you an example. Rad 3 times 0 is rational, while rad 3 times pi equals pi rad 3. Still irrational. All right. Prove that the product of two rational numbers is always rational. Equals 3 times anything, even 1/3, is 1. 3 times anything is 21. Give a couple more examples in there. Consider the following statement. The product of two rational numbers is an irrational number. Is the statement true? Never. And we're done for now.